Have you ever stopped to think about all the tiny, invisible computers that pretty much run our world? I mean, they're everywhere. But what happens when we give those hidden computers a brain? Well, today we're going to explore just that, how artificial intelligence is quietly sparking an intelligent revolution inside the everyday objects all around us. This quote really just hits the nail on the head, doesn't it? It perfectly captures what's happening. We are moving away from devices that just, follow a set of instructions to devices that can actually think and operate on their own. It's a huge transformation in how we interact with technology.
All right, so before we jump into the AI part, we really need to understand the stage where this whole revolution is taking place. And that stage is built on something called embedded systems. You can think of them as our world's hidden brains.
So what exactly is an embedded system? Well, it's a tiny, specialized computer that has one and only one job to do. It's not like your laptop, which can browse the web, play games, do spreadsheets. Nope. The embedded system in your microwave is only there to do microwave stuff. It's designed to be super efficient, cheap, and really, really good at that one specific task.
And they are hiding in plain sight, absolutely everywhere. From your car's engine controls and braking system to life-saving medical devices like pacemakers, all the way to the simple router that's bringing you the internet right now. You probably interact with dozens, if not hundreds of these things every single day without even thinking about it.
So for decades, these systems have been these simple, obedient little workers. But now, we're adding a powerful new ingredient into the mix: artificial intelligence. And that is the spark that's causing these hidden brains to kind of wake up and start thinking for themselves.
Now, I love this slide because it shows the before and after so clearly. A traditional system, it's basically like a simple script, right? If this happens, then do that. It can't adapt. But an AI-powered system, it learns from data. It doesn't just blindly follow the rules, it starts to make its own decisions. It goes from being a passive tool to an active, intelligent operator.
So why does this matter? What do we actually get out of it? Well, the benefits are massive. An AI-powered thermostat doesn't just follow a schedule you set, it learns your habits to save energy all by itself. A fitness tracker doesn't just count your steps, it learns your unique body rhythm. And maybe the best part? All this thinking happens right there on the device, which means decisions are instant. That's absolutely critical for something like, say, a self-driving car's braking system.
And look, this isn't some futuristic theory or science fiction. This AI-powered awakening is already here. So let's take a quick tour of how these intelligent devices are impacting our lives right now.
In healthcare, this stuff gets really personal and, frankly, amazing. Those wearable devices on our wrists, they're no longer just fancy pedometers. Their onboard AI can analyze our heart rhythms in real time, spot abnormalities, and potentially save lives.
The car world is a huge showcase for this. Embedded AI is the absolute core of self-driving technology. It's what's processing insane amounts of sensor data every single millisecond to make incredibly complex navigation decisions instantly and safely.
And of course, it's right there in our homes. You know when your smart speaker recognizes its wake word without needing the internet? That's embedded AI. It's making our homes more responsive, more efficient, and way more personalized.
In the industrial world, the impact is just massive. AI sensors on factory equipment can literally listen to a machine's vibrations and predict a failure weeks before it happens. This kind of predictive maintenance prevents super expensive shutdowns and keeps everything running smoothly.
This gives us a great snapshot of where the action is right now. You can see from the data that industrial automation and the Internet of Things, or IoT, are the clear frontrunners. Together, they make up more than half of all embedded AI projects. This is where the tech is making the biggest economic waves today.
Now, making a tiny device intelligent is an incredible feat of engineering. It's not as simple as just, dropping an AI into a toaster. There are some really significant challenges that have to be overcome.
The big challenge is really all about thinking small. These devices have very, very limited processing power and memory. On top of that, running these complex AI algorithms can just suck a battery dry in no time. And you have to do all of that while making sure the user's data is secure and that the device can still make decisions in a split second. It's a tough balancing act.
So how in the world do engineers actually pull this off? Well, it's a pretty fascinating 5-step journey. First, they have to pick the perfect tiny hardware brain for the job. Then comes the real magic trick. They take a huge, powerful AI model and carefully shrink it down so it can fit. That's a process called model optimization. From there, they build the pathways for the data, weave the AI into the device's core software, and finally test it like crazy to make sure it's ready for the real world.
As impressive as all of today's devices are, believe it or not, we're only at the very beginning of this. So let's look ahead to the next technological frontier, where some emerging trends are really pushing the boundaries of what's possible. On the horizon, we've got several game-changing trends. We're seeing processors being built specifically for AI, and new privacy techniques like federated learning. But I want to quickly spotlight two that are especially revolutionary: TinyML and neuromorphic computing.
TinyML is all about making machine learning so unbelievably efficient, it can run on the tiniest, lowest-power chips you can imagine. We're talking about a smart health patch that monitors your vitals, or agricultural sensors you just scatter across a field, all running for months and months on a single tiny coin battery. That's the future TinyML is unlocking.
And then there's neuromorphic computing, which is a complete paradigm shift. Instead of traditional processing, these chips are designed to work more like a human brain, using artificial neurons and synapses. This makes them incredibly efficient for tasks that need instant, event-driven reactions, like a wearable that detects a fall the exact moment it happens.
And this all brings us back to this really powerful idea. With embedded AI, our devices are changing in their very nature. They're no longer just reacting to what we tell them to do. They are learning, predicting, and anticipating what we need. They're evolving from simple tools into truly intelligent partners.
And that's really the key takeaway here. This quiet revolution happening inside our devices is completely redefining what technology can be for us. So I'll leave you with this question to chew on. As our devices truly transform from passive tools into active partners, what does that future actually look like to you?